Ever catch yourself wondering, like, can machines actually think? And I don't mean some, sci-fi robot takeover way, but like real genuine thought.
It's a question that's been bouncing around for ages, but back in 1948, a guy named Alan Turing was already on it.
Alan Turing, wasn't he the one who, like, cracked the Nazi Enigma code?
That's the one! Talk about a brain. The guy practically invented computer science as we know it.
So what, he just casually predicted the future of thinking machines back when computers were still in their, like, infancy?
Well, not exactly computers as we know them, but he did lay out his vision in a paper called Intelligent Machinery back in '48. Imagine this. Pre-internet, pre-personal computer era.
Okay, so way ahead of his time. But how do you even begin to unpack this whole idea of a thinking machine?
Well, he starts by addressing the elephant in the room, right? All the reasons people were already skeptical about the idea.
I bet some of those concerns haven't changed much, even today.
You're telling me people were worried machines would become intellectually superior to humans?
Right, like some kind of superior beings. Makes sense. What else?
They thought machines would just be glorified calculators, good for crunching numbers, but not much else.
Just like supercharged adding machines.
Exactly. And then there was the philosophical side of things. The idea that any intelligence a machine displayed would just be a reflection of its creator, not its own.
So kind of like a puppet echoing its puppeteer.
Precisely. And these concerns weren't just abstract worries. Turing actually breaks down these objections in his paper. For example, he tackles the whole machines as number crunchers thing head on.
How so?
He distinguishes between what he calls discrete versus continuous machines. Imagine the difference between a basic calculator and a car engine.
Okay, so one's all click-clack, step by step, and the other's just humming along.
Exactly. One operates in distinct steps, the other is in constant motion. Turing believed the human brain was more like a specific type of discrete machine, one that controls and processes information in a step-by-step way.
So he's drawing a parallel between how our brains work and how certain machines function. Makes you wonder if our brains are just really, really complex machines themselves.
That's a whole other deep dive. But to bring it back to Turing, this line of thinking led him to his most groundbreaking concept, the universal logical computing machine.
Sounds intense.
It was a game changer. Now, keep in mind, this wasn't a physical computer he built, but a theoretical model. Turing essentially proved that a single machine could be programmed to perform any task imaginable.
Wait, seriously? Any task?
You got it. Just by changing its instructions, or as we'd say today, its software.
Hold on, he predicted the idea of software before computers even really existed.
He was that far ahead. It was revolutionary. This idea that one machine could have infinite possibilities really laid the groundwork for the entire field of computer science.
So we're talking about building a machine that learns, but how do you even begin to do that? Like, did Turing have any practical ideas about actually making a machine learn?
He did. He actually designed experiments using what he called pleasure pain systems.
Pleasure pain systems. Sounds a bit intense for a computer program.
It's not as wacky as it sounds. Imagine trying to teach a machine like you might train a dog. Reward the good behavior, discourage the bad.
Okay, so like, give it virtual treats when it gets something right and a timeout when it messes up.
Think of it more like guiding the machine's learning process. Turing was playing around with theoretical machines here, but the idea was to create a system where the machine learns through trial and error, with rewards reinforcing correct actions. He called this the P-type machine.
The P-type machine, did he manage to create a little computer genius with this thing?
Well, it wasn't quite that simple. While the P-type machine was a fascinating concept, it definitely had its limitations.
Like what?
Replicating the full complexity of human learning, even in a simplified model, turned out to be a pretty big hurdle.
So even with this system of rewards and punishments, teaching a machine to think like a human was still a challenge. Did Turing hit a wall with this, or did he have other ideas up his sleeve?
He started to question whether a machine that just follows rules and chases rewards could ever be truly intelligent.
Right, because it's not really thinking for itself, is it?
That's the question Turing was grappling with. It's like asking if a student who aces every test just by memorizing the textbook really understands the material, or if they're just really good at following instructions.
Yeah, there's a difference between knowing the answers and actually understanding, right?
Exactly. Turing believed that true intelligence needed something more, something he called initiative.
Initiative. Now that's an idea I can get behind. It's not enough to just follow the rules. You need to be able to think for yourself, to go beyond the instructions, right?
You got it.
Like, what's the difference between a machine that can play chess by just following the rule book and one that can actually strategize and outmaneuver its opponent?
That's a great example. Turing believed that intelligence requires a balance of discipline, which lets us process information and follow rules, and initiative, which lets us make novel connections and solve problems creatively.
Okay, that makes a lot of sense.
Right.
But if we're talking about machines having those aha moments, those bursts of insight, how could we even recognize that in a machine? I mean, what
Wow.
would a machine's aha moment even look like?
That's the million-dollar question. Turing believed one way to explore this was through what he called intellectual searches.
Intellectual searches, okay.
Imagine it like a quest for solutions, like a mathematician hunting for a proof or a scientist seeking a new discovery.
So it's like how we're always trying to connect the dots and find patterns in our own lives, but on a much larger computational scale.
Exactly. Turing even suggested that most intellectual tasks, maybe even all of them, could be boiled down to this search for solutions within a set of rules or constraints.
So he's basically saying that at its core, intelligence, whether it's ours or a machine's, is about creatively navigating a complex world of information to find those hidden gems of insight.
You got it. And here's the truly mind-blowing part. He proposed all this long before we had the computational power to really explore it. Turing was way ahead of his time.
Yeah, it's incredible to think about the ideas he was wrestling with back then.
Yeah.
But there's something else, right? Like, he didn't think intelligence was just this solo pursuit, did he? He had more to say about that.
You're right, he did. He actually compared the development of human intelligence to a kind of cultural search.
Cultural search, as in, like, how knowledge is passed down through generations and stuff.
Precisely. Think about language, for instance. No one is born knowing how to speak. It's acquired through interaction, observation, immersion in a culture. Turing argued that the development of intelligence in machines might follow a similar path.
Wow, that's really interesting. So it's not about creating one brilliant machine in isolation, but about building an environment where these machines can learn from each other, share what they know, and essentially evolve their intelligence over time, kind of like we do as humans, right?
Exactly. Turing's vision was incredibly prescient. He understood that building intelligent machines wasn't just about faster computers or more complex algorithms. It was about understanding those fundamental principles of learning, adaptation, and even culture that contribute to what we call intelligence.
It really is fascinating how much his ideas from all those years ago still resonate today. This whole conversation's been like one big aha moment. But I keep coming back to this one thing, like Turing seems to define intelligence based on how well machines can perform tasks or solve problems. But what about emotions? Can we really call something intelligent if it doesn't feel or experience the world the way we do?
That's a huge question, one that philosophers and scientists are still grappling with today. And while Turing didn't focus on replicating emotions in machines, he did acknowledge the role our own emotions play in how we perceive intelligence. In fact, he actually conducted a fascinating thought experiment to explore this very idea.
Oh, a thought experiment. Okay, now you've got me hooked. Tell me more about this.
Okay, so picture this. Imagine three people, two chess players, one really skilled and one not so much, and then a third person operating a chess-playing paper machine.
A paper machine, what's that?
Basically, it's like a set of rules written down that mimic how a computer program might play chess, a simplified version of how a computer might work, but using just pen and paper.
I'm following you. So there are these three players, two humans and this paper machine, and what happens next? So spill the tea. Could people tell if they were playing against a human or a Turing paper machine?
Get this, they often couldn't.
No way. Really?
Yep. In Turing's experiment, the person going up against the unknown opponent had a really tough time figuring out if they were dealing with the human mind or just a really clever set of rules.
Wow, that's wild. So even back then, Turing was showing just how easily our perception of intelligence can be fooled.
Absolutely. This simple experiment highlights how subjective our judgment of intelligence really is. It's shaped by our own experiences, our expectations, and yeah, maybe even our emotions more than we realize.
It's like we might see something as intelligent if it can just act like we do, even if we know there's not a real thinking mind behind it. Like, say, a really advanced chatbot. You might find yourself thinking, hey, this thing's almost human.
Exactly. And Turing argued that if a machine could consistently fool us into believing it was human, shouldn't that at least make us question our own definition of intelligence? Maybe intelligence isn't just one thing. Maybe it can show up in ways we haven't even begun to imagine.
That's what I love about these deep dives. Always more questions than answers. And here we are, talking about ideas Turing put forth over 70 years ago. It's incredible how relevant his vision still is today.
It really is mind-blowing. But remember, Turing wasn't just trying to build a machine that could think. He was wrestling with the very nature of thinking itself.
Okay, I like where this is going. It's getting deep.
He saw this whole quest for artificial intelligence not just as some technological challenge, but as a deeply philosophical one, with the power to reveal profound truths about our own minds, about what makes us human.
It's like he was holding up a mirror to human intelligence and asking, what does it really mean to think? To learn, to create. And, the big one, can we capture that essence in something we build?
And that's the question Turing leaves us with. He didn't have all the answers.
Sure, that's right.
Exactly. But he gave us the framework to start asking the right questions, questions that still drive the field of AI today.
It makes you wonder if figuring out how to build a thinking machine could actually unlock secrets about our own intelligence, like Turing believed, then where does that leave us with the future of AI? It's not just about fancy robots, is it? It's about understanding what makes us, us.
And as we continue to explore artificial intelligence, we're bound to learn as much about ourselves as we do about the machines we create.
That's the beauty of it all, isn't it? It's like these deep dives, always more to uncover, more to question. So next time someone asks, because machines think back to Alan Turing, to his incredible vision. It's a vision that still challenges us today, pushing us to rethink what's possible, both in the world of machines and in ourselves.